Hi everyone, this video is for section 7.4, modeling changing amplitudes in midline. In this particular problem, we want to find a function in the form y is equal to a times b raised to the x plus c times the sine of pi over 2 times x that fits the data given. And we have that outlined here. So your input values are noted in purple and your output values are noted in green. So one thing that I do want to note is what I have highlighted in red. We're usually used to seeing the midline at the end. So we could have actually rewritten this problem as c times the sine of pi over 2 times x plus ab raised to the x. So it looks like the model that we're working with is we're changing the midline, and the midline is reflecting an exponential growth of some kind. So to begin, or mainly our goal here, is we want to uncover what those constant values of a, b, and c are. We only want to leave the x variable, so our input, and our y variable or our output open in order to actually have a working function. So to begin, I'm going to work with a pretty easy point here to help me get going. So I'm going to put 6 in for y, and that's going to be equal to a times b raised to the 0 power plus c times the sine of pi over 2 times 0. Okay, and we're going to see what this is going to do. We're going to clean this up as best we can. So we're going to get 6 is equal to a. B to the 0 is just 1. So I'm just going to, and 1 times a is just a. So we're going to go ahead and leave that. And we're going to have c times the sine of, well, pi over 2 times 0 is 0. And what we want to note, if we need to consult your unit circles, but hopefully by now we know that the sine of 0 is just going to be 0. So it causes this whole thing to 0 out. So we are left with the statement that 6 is equal to a. So we've uncovered one of our first constant values. So in order to start finding another one, I'm going to be pretty strategic, and I'm going to actually select this point here for step 2. So I'll go ahead and note that that is step 2. So I know that I have 96. I'm going to put that in for y. And I now know that a is 6. And this is going to be b. That's a bad b. Let me undo that and try again. And also get rid of all these little dots just in case they get in the way. Sorry about that. It's one of the drawbacks of using the stylus on a screen. So we're going to have b squared plus c times the sine of pi over 2 times 2. So as mentioned before, I'm being strategic about which point I'm picking. This one, as it turns out, is going to give me the least amount of a headache when I'm working through this. So if I start cleaning this up, I'm going to get 96 is equal to 6 times b squared. So there really isn't anything that I could do here. And this is going to be plus c times the sine of, well, just pi. But notice in this case, the sine of pi is just 0. So this zeroes out yet again. So this leaves me with 96 is equal to 6b squared. We can go ahead and take the square root. Oh, sorry. Nope, jumping ahead. First, we need to divide both sides by 6 first. And this is going to give me 16 is equal to b squared. Now that we have the b squared isolated, now we're safe to go ahead and take the square root on both sides. And note here that b is representing the percentage of what we have left. And also, if you recall from Math 141, b is going to have to be a value between 0 and 1. So it must be positive. So we automatically can say, we don't have to worry about, is this going to be a negative 4, is this going to be a positive 4? We know straight away that b in this case is going to be equal to a positive 4. So we're 2/3 of the way done. So, I mean, you know, that's got to feel good, right? So now let's go ahead and, for part 3 here, let's use the point 129. And really I'm picking this one because it's a smaller number, so I'm not going to have to do as intense of any sort of calculations. So in this case, we're going to go ahead and let's put up kind of a dividing wall so my stuff doesn't bleed into each other. I'm going to put 29 is equal to, I know that a is 6, I know that b is 4. I'm going to raise this to the first power. And then I'm going to do plus c times the sine of pi over 2 times 1. So pretty much as we can see here, the only variable that I have left is c, and I'm going to be able to find out what its value is. So as we continue to evaluate this, we get 29 is equal to 6, 4 raised to the 0 power, or sorry, to the first power is just 4, plus c times the sine of pi halves times 1 is just going to give you pi halves. And we can continue to clean this up. So we have 29 is equal to 6 times 4 is 24, plus c times the sine of pi halves. That's going to give us a 1. So times 1. We can subtract 24 from both sides. And this is going to give us a 5 is equal to, well, as we can see here, we just have a c times 1, so we have c is equal to 5. So our final solution then is going to become y is equal to 6 times 4 raised to the x power plus 5 times the sine of pi halves times x. And there you have it. Here is our final solution. If you have any questions or need any additional help, please come see me.